couple of things to show you. First of all, let me share my screen. So in order to make life slightly more organized for you, I have on Moodle a revised course schedule and also a revised grading scheme. So let me pop that up through here. Revised schedule and revised grading scheme. Here we go. In a minute. Okay, so first of all, we're revising the grading scheme because we're not having 4 tests plus the final exam. We're having 3 tests plus the final exam. And I think the final exam is going to be a little bit cumulative, but not a ton. So that's why I made it worth 5% more than the rest of the tests as opposed to more than that. I will get you more information on that as we continue working through the semester. Homework is now 35%. Here's the part that's interesting to you. So here's the revised class schedule. We have done 2 weeks of online learning already. Somehow or other that happened. We have 5 more left to go. So here's the next 5 weeks, the last 5 weeks of the semester. Again, the 3rd test is next week, Friday, April 17th. We talked about that already. Homework is due today, and I didn't double check how many submissions I got, but I can in just a minute. And then here's the rest of the homework due dates for the rest of the semester, and this is wrong. I will fix it. This should be sections 5.1 through 5.3. Sorry about that. I'm just seeing that now. The dates are correct. This is just sections in chapter 4 instead of chapter 5. My bad. So this is posted on Moodle. It is the schedule for the rest of the semester for you. You can kind of see where we're going. Notice that this week we don't have class on Friday because that's Good Friday, but we do have class next week, Monday. You should have gotten an email from WLC administration, etc. Originally, that was a day off, but you did get an extra week of spring break. So we are taking that Monday back, and we will have class on that Monday. And then I also didn't put it on here, but I should. The final exam, I believe, is Wednesday, May 13th at 10:30. I'm pretty sure that's when it is. So we will plan on the last test, which is sort of cumulative a little bit. We'll figure that out as we get in there. So this is posted on Moodle, and I will fix the sections 4.1 to 4.3 to be 5.1 to 5.3. Any questions on that schedule before we keep going? Anything there? Questions on that schedule? No, we're good. Okay, let me do a quick check here and see how many groups have turned in homework. I have 2 groups who have turned in homework. I won't pop up who it is, but 2 groups have turned in homework. Remember that homework is due this afternoon at 2 p.m. So get that homework turned in before 2 p.m. All right. Other general questions before we get going with differential equations? Anything in general, content, format, schedule, anybody, anything? Now is a good time to ask. All good? Okay, so let's do a whiteboard here. For the 850th time, we are in the middle of Laplace transforms, and we are trying to make it so that Laplace transforms are easier to find the inverse of. That is what we are looking to do. So we are still in section 4.4, and today we're going to do derivatives and integrals of transforms. Derivatives and integrals of transforms. Fair warning, and the reason I'm telling you this is because you can't read this, but that's okay, needed to write myself out a cheat sheet. So this section is super easy to get confused. Am I dividing by t? Am I multiplying by t? Am I taking a derivative? Am I taking an integral? I am working off of my cheat sheet. I would encourage you to make your own cheat sheet as well. I'm going to put down all of the results from the section that we have first, and then we're going to talk about, okay, what's the summary of these? How can we keep them straight? And then we'll do some examples. So all of the results from the section first. Here's what we've got. And these are in my notes if you want them. First of all, the Laplace transform of t times little f of t is negative f prime of capital S. That's the first one. Laplace transform of t times little f of t is negative capital F of S. I am also going to write down that there is a generalization in my notes. So if you are multiplying by a higher power of t, I'm not going to make you do that. I don't think it shows up in the homework either, but if you have like t squared or t cubed, there's a generalization in my notes. So you can look for that there, but this is the one we're mostly going to use. We can do that backwards, and I'm going to take the negative over to the other side of the equation. So we can also say that the inverse transform of capital F of S, the derivative, is negative t times little f of t. Negatives can go in and out of Laplace transforms because they can go in and out of integrals, and that's what Laplace transforms are, right? So we can just take the negative over to the other side of the equation. Inverse transform of capital F prime of S is negative t f of t. Okay, third result, here we go. Laplace transform of little f of t divided by t. So instead of multiplying by t, I am dividing by t this time. Laplace transform of little f of t divided by t is the integral from s to infinity. And now I can't have an s inside because I gotta have a different letter. Remember when we had t in the limits, we switched to tau inside, right? So when we have s in the limits, we're gonna switch to sigma. So capital F of sigma d sigma. That's the third one. Number 2, I wrote down wrong. I'm sorry. Can we go back and change 2? The right-hand side, instead of a negative t, needs to be a negative 1 over t. I am sorry, that is wrong. Could you please rewrite? Number 2, inverse, nope, wait. Told you the section was confusing. Hang on. Inverse Laplace transform. Yeah, no, we're just rewriting 2 all the way. Okay, let's rewrite 2. 2 totally needs to get rewritten. That's correct. So I should be able to take the inverse. No, sorry. If I were doing this in class, then you would be talking to each other and I would be doing much better. That's an f of t. That's right. Yeah, no, we're good. Okay. Inverse Laplace transform of capital F prime of S is negative t times little f of t. Yeah, that's right. Is that what I had in the first place? Oh my goodness, I am sorry. I don't like this section even when you're all there in person, and I like it much less when I'm staring at a computer screen. Okay, that's 3. We're gonna go with that. Here's 4. Here's what we've got. Number 4, if I want to do the inverse transform of an integral from s to infinity, capital F of sigma, d sigma, then I am going to get 1 over t times little f of t. So that's just reversing number 3. Just reversing number 3. Inverse Laplace transform of an integral is 1 over t times little f of t. All right, as I just demonstrated to you, it is super easy to get those confused. So let's do cheat sheet here. I'm gonna do the next whiteboard because I don't think it's all gonna fit on this one. And then we'll talk about why each of these are useful. So helpful tips. These are gonna be easier, but you need the original things to start. So helpful tips. First of all, we want to do tips for calculating the Laplace transform, so going forwards. Helpful tips for calculating the Laplace transform of little f of t. Those are going to be our first helpful tips that we come up with. Calculating the Laplace transform of little f of t. Two things. First of all, if you are multiplying by t, so if you're multiplying by t, then what you want to do is multiply by -1 and take a derivative. So if you are multiplying by t, multiply by -1 and take a derivative. That's your first helpful tip. If you're multiplying by t, multiply by -1 and take a derivative. If you are dividing by t, so if you are dividing by t, then you want to evaluate an integral. There is no -1 in this second part. There's a proof. We can demonstrate why it works. I am not going to, but there's a proof and we can demonstrate why that works. So if you're multiplying by t, multiply by -1 and take a derivative. If you're dividing by t, you want to evaluate an integral. I will do examples, I promise, lots of examples. The second thing that we can do is for calculating the inverse transform. So the inverse Laplace transform of capital F of S. So two things here. If the inverse transform of the derivative is easier, so that's a possibility. If the inverse transform of the derivative is easier, then you need to multiply by -1 and divide by t. If the inverse of the derivative is easier to do, multiply by -1 and divide by t. If the inverse transform of the derivative is easier. It might also turn out that the inverse transform of the integral is easier. So if the inverse transform of the integral is easier, then we want to multiply by t. If the inverse transform of the integral is easier, then we want to multiply by t. This is all abstract. I'm not even going to ask for questions after this because none of it makes sense right now until we do some examples, and I am perfectly fine with that. All right, so helpful tips. There's two things you want to think about. First of all, am I doing a transform or am I doing an inverse transform? That's the first thing. Second thing, if it's a transform, am I multiplying or dividing by t? If it's an inverse transform, is the derivative or the integral easier to work with? Okay, those are your kind of flow chart questions. Transform or inverse transform, multiplying or dividing by t, and which is easier, the derivative or the inverse? Examples, lots of examples. But let me stop sharing so we can pause the recording and chunk it up here.